Hey guys. So for this lecture, what I'm going to record or what I'm going to go over are three examples of electromagnetic waves, wave examples. So three questions that you may see in the future. So for the first one, what we want to do is we want to calculate the wavelength of a wave where we know the frequency of it. And then part two would be we want to calculate the frequency of another wave if we know the wavelength, so kind of like inverse. So to solve these types of questions, if you have one and not the other, is to use the relationship between frequency, wavelength, and the speed that the wave propagates. Because we're talking about EM waves here, they'll propagate at the speed of light. Okay, so C, 3 times 10 to the 8 meters per second. Okay, if you're not told that it's moving in a material with less of a speed, then it'll just be the vacuum speed of light, or the speed of light that propagates in vacuum. So for part A then, what we just want to do, 60 hertz, that's the frequency. So the wavelength will be C over C divided by the frequency, 3 times 10 to the 8th meters per second over 60 hertz. And so what I get is actually a fairly large wavelength. This will be even larger than a radio wave, so pretty massive. Here we go. So it's just 5 times 10 to the 6 meters, okay, if you just divide that out. So the next one, so the frequency, so the second part then, so part 2, you're going to use the same equation, but this time you're going to solve for the wavelength. So wavelength equals C over the frequency. Or, sorry, we're solving for, I'm losing it, frequency this time. So 3 times 10 to the 8th over 10 to the 3 meters, which is just 1,000. And what I get is 300, roughly 300,000 hertz when you divide that out. Okay. So that's how you solve those types of problems. We also discussed other types of problems, like this one. If the electric field in an EM wave has a peak magnitude of 0.72 times 10 to the minus 4 volt per meter, what is the peak magnitude of the magnetic field strength? Well, that's a good question. If you remember, we actually had a relationship between the maximum amplitude of an electric field and the magnetic field with C here as well. And it was this equation. So what we want to solve for is what is the peak magnetic field strength. So we're just going to move this over and this over here. So this turns into B naught equals E naught over C. And if you want to go ahead and solve for this, you get B naught equals the 0.72 times 10 to the minus 4 volt per meter, and then 3 times 10 to the 8th meters per second. You plug that in, and you get 2.4 times 10 to the minus 13 Tesla. That's the maximum amplitude of the magnetic field in that situation. So the next type of question you may encounter, and what you'll see about most of these is it's really just kind of plug and chug. You have all the equations, you just need to pick the right form. And maybe there's some trick there where you need to convert from meters to, you know, something centimeters to meters or something like that. But most of the problems I give you are in use standard SI units, so just pay attention. Okay, so if the amplitude of the B field of an EM wave is this, Okay, so this is B naught. What is the average energy transported across the unit area by the EM wave? Okay, so average energy transported would be the intensity. And if you remember, there was an equation for average intensity, so that's what we're going to use. Because this takes place across some time. So that was 1/2. The form that's most useful to us is 1/2 C B naught squared over mu naught. Okay? And so if we just plug this in, so we just write 1/2, and then we do 3 times 10 to the 8 meters per second. And then B naught squared was the 2.2 times 10 to the minus 7 squared. This can be complicated to plug in. And then mu naught was 4 pi times 10 to the minus 7. Okay. You plug all that in, you get 5.7 watts per meter squared. Okay. So that's pretty much it. Yeah. Another word for that, I guess, would be power. So yeah, those are just some types of questions that you may see with electromagnetic waves. So thanks for watching, and I'll see you in the next one.